Hey everyone. So I'm Rachel Sweeney. Been a DevOps engineer at the Pew Research Center for almost 2 years now. And before that, I was an executive assistant with a degree in Chinese history. Very lucky that despite this promising pedigree, I somehow managed to trick a number of companies into offering me employment. And I've been in this space ever since then. A little about me, I love automation, efficiency, learning about new technologies. As we were talking about earlier, I love the fact that we can attend virtual meetups in Columbia, DC, Amsterdam, San Francisco, wherever. So enough about me. What I want to try and do with this talk is I want to try and put y'all in our shoes here at the Pew Research Center by quickly explaining who we are, what we do, and then talk about the problems that we've had and how we've attempted to solve it. So I'm really curious to hear about what you think is good or bad about this workflow we're developing, or if there's something you would do differently. And I'm going to start out very broad, kind of like at a higher level, a higher view, and then just slowly go in and get more and more technical from there. So if you're not familiar with the Pew Research Center, we're a nonprofit. We're a fact tank that informs the public about the issues, the attitudes, and trends shaping the world. We're nonpartisan and non-advocacy, and this part's important, meaning we do not take policy positions or make recommendations. So essentially, we just study, look for the data and let the data speak for itself rather than trying to put our opinion on it or put our view of what the data says. We just put it out there and let other people take it and go from there. And we do this by conducting public opinion polling, demographic research, content analysis, and for what we do on my team, data-driven social science research. So the team that I work on deals with computational social science issues. So examples of this would be collecting Twitter and Facebook data or downloading church sermons to find out what people are hearing when they go to church on Sunday. So for example, what are American legislators saying about immigration? Or what political content are Catholics hearing in their sermons, if any at all? In order to get this data, a few different researchers on our team have written code to collect data from various APIs or to simply scrape it from the web. We're constantly looking at new data sources, either through flat files, such as buying mobile phone data to see if we can track immigration patterns, or discovering a new API and building code around it. As you can probably guess, we have code to collect data from Facebook, Twitter, and to scrape some types of information off websites. We've worked a bit with the Reddit API, and hopefully soon we'll start working on collecting data from TikTok as well. And this is right about the point where we start to get to the problem that we've had over the past couple of years. So let's say you're a researcher and you want to study legislators on Twitter. So these would be members of Congress, the Senate, etc. Now, previously, we would set up an environment that we can see on the left-hand side, environment A. We would give it a list of Twitter handles that we want to collect data on. We can see the data scientists feeding in Twitter handles, and we run it on some interval, probably via a cron job. So this creates a pipeline for putting data in, collecting it, and loading it into a database. Now this works fine, and as a result, we're going to have a database filled with data that look exactly as we expect it to. Now let's say another researcher wants to study a panel of individuals that is representative of the population of the United States. This is a different group of people, and it's a different project. So you can see here in the middle, we have a new pipeline. We get their Twitter handles via survey. We set up environment B. We put Twitter handles in that we received into the same software code used to collect Twitter data. And now this data collection occurs at some interval. So we now have a completely separate pipeline for putting in data, collecting it, and loading it into another database. And again, this is fine because the data in project B look exactly as we expected to. So 2 different projects and 2 different pipelines. Now this process is going to repeat itself every time we have a new project that wants to collect Twitter data, and it can't be grouped together with one of the previous projects. So now let's say we want to study an issue like the 2020 election, and we want to compare how legislators talked about it, the data from Project A, to how different Americans were talking about it, the data from Project B. The problem we now have is that these two projects could have been collected at different intervals. One project may have chosen to collect some types of data, but not all. The versions of code used to do the collecting could have been different, and they were most certainly collected in different environments. So this makes studying data across projects a lot more challenging for a data scientist, because since there's no agreed upon standard and system for collecting this particular type of data, each project has a lot more differences than are necessary. And not only that, but simply moving from one project to another requires an additional cognitive load to remember and recognize the unnecessary quirks between the two projects. Now, there will always be unique data and features about each data set, but we can certainly minimize as much as we possibly can with all the unnecessary ones. And then lastly, from an overhead perspective, these are multiple different systems with different environments. They need to be created, maintained, and the right users need permissions to access them to be able to start data collection or poke around in the machine when it wasn't working properly. So previously, the data scientists would, in this instance, SSH into these machines, and then they would kick off data collection. And a lot of times they would be doing it differently from other projects and other data scientists. So in our current system, and this is a work in progress, something we're playing with, we currently have one environment with one system feeding it. So rather than having multiple pipelines for feeding in data and getting data out, we've set up one pipeline that all data goes through, and then it gets filtered out to the correct database at the end. So the system is declarative, and researchers interact with it by declaring what they want to collect through DynamoDB, a NoSQL database. When we want to collect data for any project using any data collector, be it Facebook, Twitter, the future TikTok collector we've yet to develop, whatever, we make the declaration here in this NoSQL database, the first step that people can put data into. So for example, I want to collect Twitter data using this specific list of handles. Please use this API key and send it to this database, and I want you to collect it every single day. So another benefit of this is that this provides now a centralized record of every collection request and collection attempt that was ever made, with status updates, how long it took, when it was completed, etc. So these requests are then going to go through a series of logic steps afterwards to pass the data to the data collector. And we can see here that in this instance, these are Lambda functions in this diagram. Eventually, when it gets its way to the data collector, that's where the collection is done. And the Twitter data collector doesn't care if it's collecting data for project A, B, or project Z. All it cares is what information is given to it to start running. So one day it could be collecting data for project A and sending it off to project A's database. And the next, it could be collecting data for project Z and sending data off to project Z's database. It's the same environment and the same code every single time, or it's the same Docker image at least, which has the same setup. So only when the data is sent to different databases does the pipeline veer off and segment into a more project-specific pipeline at the end. If anyone has any questions, does this make sense from a high-level view at this point?
What's the K on that diagram past Elasticache?
That's a good question. So that's Kubernetes, specifically EKS is the version that we're running. And yeah, that's where we host whatever data collection software that we're using, and it's going to pull down data from Elasticache.
Gotcha.
I have a question. My name is Chax. So in the previous slide you have where you have parallel different, couldn't you solve that problem by having the same, like a standard declarative format for requesting this data, and then still run them, and then you can now sum them up together because now you know the standard pattern of your request, if what I'm saying makes sense.
What would that look like? Is that like launched by Terraform or launched through, what triggers it, I guess?
So it's the same idea that you have in the second slide, where you send your request through a database, but then when I'm saying that request spins up the three independent pipelines. So in other words, you converge and then you come out of it again, and each pipeline will be running separately too. Would that also help you or help solve the problem that you were having?
That's a good question. I'm not entirely sure. I think eventually it's going to come, eventually it gets to the point where compute needs to be done or where the collection needs to happen. And I guess here in Kubernetes, like let's say, for example, we have 3 different projects all wanting to collect Twitter data at the same time. And so we now have, they end up in Elasticache. At this point, there would be 3 different pods in Kubernetes running, but they're all running the same Docker image. So it kind of is like 3 different pipelines, but they're all in the same environment and they were all triggered from the same
Right.
origin.
Okay. Makes sense. Thank you.
I'll move on and get a little bit more technical from here. So yeah, what does this look like technically? So to dive a little deeper, we have 2 different tables in DynamoDB. The first is a query table, and this is where we put in a request to the system to collect data from Twitter, Facebook, whatever location. And it's either a one-time data request or it's a recurring data request. So at the moment, we're just processing Twitter data while we work through some of these issues, but we're have plans to migrate more data to this pretty soon. So data from this table, from this first query table, it's going to be processed by the Lambda functions. And eventually it's going to find its way into our second table, the jobs table. I should probably mention, if you're looking at this Pontifex right here that comes before things, Pontifex is just the name for this whole system. It's the name that, we gave it like our pet project name. So that's where that comes from. And so yeah, eventually this information is going to end up being in the jobs table. And from here, if you're not familiar with Lambda functions, this is the process that gets it from one table to the other. Lambda functions, in short, are a relatively simple snippet of code or a function that gets executed by Amazon on their servers based on some trigger. So if we want to say, let's take this particular action, we throw it up to Amazon, they handle it, they host it, and then it just gets executed on the trigger. So now that the Lambda function has put this data into the jobs table from this queries table, this is the table where the actual executions of these requests take place. So separating these out into 2 tables allows us to keep track of every time data was collected, along with how long it took and all the other information that's helpful to researchers. This is again going to be processed by another Lambda function, and it's going to put all this information into the Redis queue, ready to be processed by the data collector. We made a simple UI, and I'll just show you this real quick to hopefully help it make a little bit more sense. So I mentioned having a centralized log of every collection request. And so yeah, now we've got this pretty basic UI. It still needs a bit of work, but it's just easy for us to quickly search through before this potentially gets released to more data scientists. The censored out items are the Twitter API keys. They're secrets, but they're not really huge secrets. It's all public data that it's scraping, and it's within a private VPC that doesn't have access to outside. And yeah, from there you can see the rest of the information around it are the parameters for getting the data collector to collect the information that we want. We can see this being in the query table, the first table, we can see we've got a schedule on the far right based on a cron job. So that says, with what frequency do we want it to run? Last scheduled says, when was this last, when did it last instantiate or create a job to start data collection? Enabled shows whether it's still a recurring job and we still want to keep creating jobs from it. And then under command parameters, you can see this is all the relative, or all the data that the collector needs to do its job. So the Twitter collector expects all this information, and I've kind of just packaged it up into this, this value here, and it gets fed along all the way to the collector. So things like max spec, fill dates, the profile set, these are all things the Twitter collector needs to do it, to work however it wants. And then from there, the command name, these data collectors, for example, this one will collect all the tweets from the people in this profile set or this list of users. It will do link expansion, and I think it gets their profiles. And so that's going to run every single day. Whereas once a week, we will run get followers. So we'll go over that same list and we will, check to see if there's any changes between who has followed these people or who they're following. And they just iterates over once a week or every day. So from here, going to the next table, so we just looked at the queries table where those first requests go in. From the jobs table, on the other hand, now this is going to show every time data was collected or attempted, or rather when it was put into the Redis queue to be queued up. And so here we can see how long execution took, whether or not there were any issues, and what time it finished. It's still, the status right here at 30, this says that it collected, it got to 100%, it was completely done, we didn't have any errors. We should probably set that to 100, but we can see that everything here collected without any issues. Results are some debugging information that we can use if things aren't working correctly. We can still see the command parameters are being wrapped up and just packaged along all the way to the collector. And then we can see how long it took. You know, the collect tweets every day takes about an hour, so not too bad. We can see the command name, when it was last scheduled, the 25th, 24th, 23rd, every day, and go from there. So we've got these two tables here in DynamoDB, and we want to automate this whole process. Before I get a little bit more into it, does that make sense? Does anyone have any questions?
Yeah, so it looks like the jobs are going into Elasticache for Redis. Why do the jobs write back to Elasticache and take them out of the cache when they're done from Kubernetes, or why not use something like SQS or some traditional like queuing system?
Yeah, so we were using, so Elasticache is running Redis, and we did use SQS briefly. I think one of the reasons we switched to Redis was to get, I think it was for the heartbeat signals of the workers to make sure they were still running. Right now, you know, when a worker picks it up off of Redis and it takes the job, it's going to write back and it will update the job status here in the table. So at this point, the table is kind of disconnected and it's really just the metadata that we care about. So the researchers can see, you know, how things went and when they were updated. And so yeah, we used Redis so that we're using Celery in this instance with Python so that Celery could, you know, being on Kubernetes, if it gets interrupted, we want to be able to put that job back on the queue so that that way it can pick it back up and we make sure that all that data gets collected without interruption. And we found that, yeah, there were just more technical features that we could use with Redis that we were limited to with SQS. All right, so I'll dive in a little bit more. So yeah, we've got these two tables. We could see how they worked. And we now want to automate this whole process. So when we first set up a query to collect data, this is going to be an insert record right here into this query table. And it's automatically going to get picked up by DynamoDB streams. If you're not familiar with DynamoDB streams, essentially it just takes a snapshot of new inserted records or modified records or deleted records, and it holds it for 24 hours or some other short interval. And more importantly, this allows us to trigger a Lambda function. So we put the data into DynamoDB, an insert record. DynamoDB streams is automatically going to pick this up for us. It's going to trigger the Lambda function. And now our code inside this Lambda function is determining if we should collect this data request now or in the future based on what we just told it. So I should probably mention that at this first Lambda function here, there's actually two different Lambdas. One goes over the enabled or recurring jobs every 5 minutes to check to see if they need to be collected. And the other one, the one that is fired off from this DynamoDB streams, it's going to see if there's any jobs that need to be collected immediately. One of the reasons for separating these out is because we may want to schedule a collection job for 2 months ahead of time, or we may want to schedule a job to be run immediately. A lot of people on the team wanted to know, you know, if after, for example, one of the presidential debates, would that change who people are following on Twitter? And so we can schedule that, you know, way ahead of time for each presidential debate. So from here, I'll jump into one of the Lambdas real quick, just to take a quick look at this logic. So if you look at this first Lambda function, we can see that it's going to process jobs that need to be processed immediately. So we can see here the content from DynamoDB streams. It's going to come in as this event. And then by line 27, we're just iterating over all the records that we've been given. We're specifically looking for insert records. In this instance, we don't care about modified, we don't care about deleted. And from here, we're going to grab the primary key in DynamoDB. So the collection type and the UUID, this represents the primary key for the record. And then from there, we can check, is this enabled? And if not, we're not going to worry about it. Does it have a schedule? If so, it needs to be scheduled in the future. And so we're not going to worry about it. We only care about jobs that are being scheduled right now for this particular Lambda. So at this point, by line 44, I think you can see job with a capital J. This is essentially a Python, it's a module that wraps DynamoDB and just makes it a lot easier to work with. And so using that, we're just taking all of that data that we got in the query table, and we're just writing it into the jobs table so that this can kick off the next Lambda. So now from here, we just walked through that code. It writes the job into the jobs table here, goes into DynamoDB streams, and we're now into a new Lambda. And this is the one that's going to put it on the Redis queue. So again, DynamoDB streams comes in through this event. We're iterating through the records, making sure we get all the right information that we need. And eventually, we've got, I think one of the environment variables is the address for the Redis queue. And so we've got that Redis queue here, and we're checking to see that if this is not a job that starts with Twitter, so this Lambda function is just interested in Twitter jobs since it's using Celery to put it into the Redis queue. If it doesn't start with Twitter, we're going to ignore it and assume that somebody else takes care of that and does that scheduling. Otherwise, this is a job we want to collect. We're going to put it onto the Redis queue, and then we're going to write back some results back just to say that like this is now in the queue, it's ready to go, ready to be collected. So to walk through the full pipeline one last time, we've just put in a request for data right here in the query table. Saying we want to collect this data right now. An insert record gets created, gets automatically added into DynamoDB streams, triggers a Lambda function. This Lambda function determines whether or not this particular record needs to be collected now. If so, it's going to write it to the jobs table. The new record in the jobs table also finds its way into DynamoDB streams for this table, and it's going to trigger a second Lambda function. And then finally, this last Lambda function is going to take the information, as we saw in that Lambda, take everything that was given, write it to Redis, host it in Elasticache, along with all the necessary information, the API keys, the list of user handles, it's all just getting passed along. So now that we have a job in the Redis queue waiting for us, we have a lot of options and flexibility. Our team uses Python and R, with most of our data collection being written in Python. But the system should be flexible enough that if a future data collection tool were written in some other language, it could theoretically pick up that job at this point and work with it with what we've got in the Redis queue. So for our Twitter collector, we mentioned we're using Celery, and we've been pretty much able to just set this up and let it run, and we haven't had any issues for the most part. We've got a lot of triggers going to Slack, so if there's any, if Lambdas take too long, we'll get notifications. If there's any bottlenecks and any of the components, it's just going to immediately notify us in Slack. And then finally, our data collectors are running in pods and Kubernetes, and so it's going to take over from there. And yeah, those pods could be in any language, provided we're able to write it to the Redis queue in a way that the pod, in whatever language it is going to be able to recognize and work with it. Now, I imagine that once we start to have issues with scaling, we will probably address this and try out a more push-based workflow, because right now it's all a pull-based workflow. So the collectors could hopefully scale to 0 when not needed, and then scale up to however many are needed on busier days. So for the most part, that's the system, minus some other, extra little pieces surrounding it. If you have any questions, I'd love to hear them. Anything else? And additionally, if you would have done things differently, or if there's like a more efficient way to do some of these pieces, I'd especially like to hear how this could be done differently, or how other people think about it. At this time, it does feel a little bit more complex than it needs to be. But I think to meet the goals of having logs for every job that was ever executed, regardless of which data collector it's going to, or having all this centralized, along with queuing up the jobs for scaling and being able to update the data collectors, it's worked for us pretty well. And for the most part, it's just been running without any issues. And that is all I have.
That was great. Thank you.
Of course.
I have a lot of questions, but I'll let everybody ask before I do.
So I have one question, just it's kind of a comment. do you see whether this new system you have will help you to do data validation or um, source new data that you never thought of in the future with high confidence, just because you have this system designed this way? Let me give you an example. So maybe today you're sourcing data of all the cars bought every month, and then you have an API that you're calling to get that information, and then you set up another job that gets all the airplanes that you bought, that people are buying or businesses are buying. But then again, you need to get all the fuel consumed, but then you don't have an API for it. Do you see this helping you to kind of, because you now have, the cars that you're getting every so often, and you know the planes that people are getting, now you can easily use that to extrapolate how much fuel is being consumed, or to verify an API that sent you fuel information, by comparing the cars and the planes that you got. Do you see that maybe helping you better? I don't
Um,
know if that makes sense.
yeah, I'm trying to make sure I understand. I know one thing I will say is the things that go through the system are, they depend on a data scientist having already created some code to collect whatever they want.
Mm.
And then I guess, are you saying like if you have two different pieces of information, being able to extrapolate a third one based on what's in the
Right.
database?
Yes, based on, because now you have a standard. You've already standardized the way you collect this data. You can easily refactor to extrapolate another data point that you never thought you were going to have in the future. Do you see this helping you better than previous architecture that you had?
That's a good question. I think it does. I think we're better poised to be able to do that. I think that would mostly, that would be a situation where a data scientist would realize or come up with this third piece of information that they could get. And if the way we put in the query to collect the data didn't quite match up, then
Mm.
we could always change it and get more information. But I guess at that point, hopefully we've cut out as many different unnecessary variables that made the two projects different, to where they would have the best shot at being able to extrapolate that information.
Yeah, okay.
Yeah, I guess it depends on, yeah, there's a lot
What
of,
it is.
yeah.
Thank you.
Hmm.
So I was kind of curious. So say I'm a researcher and I want to collect, say, pick something easy, Twitter data for, let's say, a week. How does the job execution? I understand how it gets into and kind of right up to Redis, but then once it gets into Kubernetes, is that a cron job that runs on a set basis with a specific end time and start time, or is that just a regular job that is then like killed by something after a week?
Yeah, so right now, yeah, we are using a pull-based workflow. And so these collectors are just sitting in Kubernetes, constantly listening to the queue, being, do I have something to work on? Do I have something to work on? And if they do, then they're going to pull that data down, do all the collecting, send it off to the database, and then they just stop right there and work, or they just wait for the next job, or they just keep going
Gotcha.
as a constant queue.
Okay. And you mentioned scale to zero. Have you seen, I'm sure you've seen Knative.
It's funny you mentioned that. That's exactly exactly what gave us the idea. Because yeah, we would love to do that, but like right now, we don't need it. There's not enough resource. It doesn't use enough resources that we really needed to go that low. But we would love to integrate that, especially as it does scale up, and we need it to scale more. So.
Yeah. And then is there any need for HPA on your cluster, horizontal pod autoscaling? Because we've used that and it's pretty easy to set up because you can kind of baseline your pods when they're empty and be like, oh, they use like 1 millicore, and then if they spike up, they automatically scale up.
Yeah, that's a good question. We haven't, we've played around with it a little bit, not for Pontifex or for this particular system, but Yeah, that would be a good solution as well, is just to, there's the baseline activity of not data collecting. And then as soon as it passes a very low threshold of suddenly data collecting, yeah, why not create another pod that's just listening to the queue? Yeah.
Yeah, yeah. And you could even, if you had a queuing system like that where it's pulling, you could even set up custom HPA where it spins up one pod for one task and then it just dies after that. Which I did get working, so it's possible. It took a long time though. It took a couple weeks.
Yeah, I love the idea. Kubernetes is just so much fun, all the scalability and potential.
And then it looks like all your job tracing goes back to Redis or back to DynamoDB.
A little of both. So in the yeah, with Celery and with, I think we're using Django for one of these collectors. And with that, as it goes through certain stages, it's orchestrating the different functions throughout the Twitter collector. And so it's saying, did I get this data correctly? Does everything make sense? If so, write back to DynamoDB like a status update saying like, okay, we're one step closer to our goal. At that point, it's going to kick off the command, pass it all the arguments. And then while it's doing that, it's going to write back another status update to DynamoDB, to the jobs table. And it's going to say, great, we're now collecting data. So here's an update. We're actively collecting. And then when it finishes, it's finally going to write like a last message to the jobs table saying we've finished collecting, didn't have any issues. Or if there were issues, then it would write like a negative value, just saying this failed at this step and here's where you should look into it. And then separately, yeah, Celery will manage Redis at that point. So if it does get interrupted, it will, if it's a graceful interruption, which we have set up in Kubernetes, then it will put that job back on the queue. So they're really it's writing back two different places for two different reasons. One being the metadata for the data scientists, so they can know how things went, how long it took, when it finished, et cetera. And the other for the, functional utility purposes of like, have we collected this data? Do we need to recollect it, et cetera?
Does it capture errors? Just if it bombs out for some reason.
I think it does. We've got a column in the jobs table that does collect all of that information. Thankfully, we haven't had that issue. So we probably designed the system maybe a year ago, and like for almost this entire time with Twitter, it's just been collecting nonstop without any issues. So yeah, thankfully I haven't had to look into that, but I'm pretty sure it does collect the error there.
Okay, cool. Yeah, we're using Elastic APM for that, the free version, but it would be really cool to play with X-Ray. I know AWS has that. Oh, geez. Oh, and then if the scale for the researchers, it looked like it was Postgres databases. Are they using some larger thing like Hadoop or Redshift or anything like that for larger scale exploration of data?
So we haven't had to do that, at least certainly not for these Twitter projects. Typically what we'll do is we will focus in on like a slice of big data. So like rather than just collecting, mass Twitter things, like we have very defined lists of people that we want to follow. And so, yeah, most of this data is in like the, single digits of terabytes. Like they're not like huge data sets, but we have, there's one other DevOps engineer I work with, and I'm pretty sure before I started, he had set that up for like a one-off project where we did need to do something like that.
Okay, cool. Because I know some of the data scientists I work with were thinking about Kubeflow, but that's more machine learning. So, yeah.
Yeah, we've trying to remember the context. It's been a while, but we wanted to work with that with we've got Jupyter Hub on Kubernetes, and it'd be nice to be able to give data scientists access to GPUs through that just by letting them spin up their own server when they want.
Yes, that would be very nice.
So when you collect the data, does it all go into like the same database, or does it have different schemas depending on where it comes from? And how do you ever age something off, or do you just keep growing, or how do you deal with that?
So right now, it's a good question. So if for the most part, they are different databases. There's a couple we've been able to lump together for 2 different projects because they're similar enough. But yeah, for that, they are different databases and they're using the same schema since they're using the same data collector. And then we have aged out some data for different things. Like we used to do machine learning to recognize gender, looking at different photos to see, like, if you do a Google search and you search for like a career, like what gender do you see, or just like how often do those things come up? And those data sets and that material, like we will age those out. But for the Twitter stuff, it's been pretty perennial in the sense that just there's always something to study and something to write about. And so yeah, we've got a couple of projects doing Facebook, Twitter, mostly following legislators, and those have been collecting for about 5 years without stop. So
Cool. Do we have any other thoughts, comments, questions?
So, Rachel, I have a question. Where in the, I'll say in the Pew hierarchy of things, does the question of the veracity of the data come in? What you've described is an elegant technical solution to a system that presumes either, well, I'm assuming, that's my question, that all data is correct. What happens when, because of the herd instinct in Twitter, people get whipped up on stuff that may or may not be true? And is that a data scientist a problem to resolve? Or from your perspective, are there things that the collection system could do that individual queries and individual projects by individual data scientists may not see? Is there could there be almost a technical solution to what amounts to a social problem? I'd just be curious as to your thoughts on that.
yeah, that's a good question. So a few things. I guess first, the data scientists have very carefully selected the list of who we're going to study. And it's a real challenge because we want to make sure that it's, if we want to say like members of Congress have said this, we need to make sure we have every single member of Congress, and like we can't miss anybody. Like it has to be the complete 100% list. Otherwise, it really limits what we can say, because then we have to start going into subgroups from there. And additionally, yeah, when it comes to like determining whether or not something is, if people do get whipped up and whether or not they're saying something that's true or false, I guess from Pew's standpoint, like we are not going to be the judge of those things, but what we will say is that they were said, and they were said by maybe this % of Democrats, or they were said by this % of Republicans, or there could be some other break by, gender or just location or something different like that. So in terms of integrity, we know that we have the full, complete list of people, and we know that that is true. And so from there, we can say like, what was said with irregardless to like whether or not it was true. And as for whether or not we can incorporate more into the system, when we were planning it, we did have aspirations of doing that. And it certainly would be nice to just, I was just constantly thinking like, how can we take more work off of the data scientist plates? Like, what are things that they're doing regularly? Can we put it in the system and automate it? And we've had challenges.
That's really where my question stemmed from, is what could you do, given you have in some ways access to, you have access to everything. And often, at least in my experience, people don't know the right questions to ask, and don't know when they ask a question if they're being misled by the data that they get. And I'd be curious, because how you would deal with, how you help the analyst if in fact they're asking what seems to them to be a reasonable question, but the preponderance of the data would say that they're off track.
I feel like that is at least to me right now, I think that's a harder question to answer from the, the perspective of the pipeline. I knew that when it does come to asking those questions and making sure that they are good, valid questions, yeah, we basically have like a hive mind where, many members on the team get together and just try and pick apart, like, why might this be biased in some way, or what's wrong with this question? Why isn't it a good question? And so, yeah, from that perspective, I do think it's harder for the pipeline to help out. It's not to say that we can't somehow, like, yeah, is there some algorithm that could generate some questions, but then, is that introducing bias somewhere? We've tried it a little bit simpler with just almost like, cleaning tasks of getting all those links on Twitter where they're like shortened URLs of like 15 characters or so, and just like automating the process of automatically expanding all of those, because eventually those short URLs go away and we still want the history of, the full URL. And so little things like that, like not quite data cleaning, but just like the things that need to be done to maintain the integrity of the data in the long term. Those are things that we have been able to work into it. So.
Thank you. That's that's a good answer to an unanswered hard problem.
I wonder whether the Python, for example, Python data validation tools that you can incorporate in pipeline ELT systems could be able to help out, do something like that. You remember what I was saying earlier, where you infer data from some other sources and then correlate it together to kind of see whether it is correlating or not.
Yeah, we certainly talked about that. I think one challenge that we have is on the DevOps team, there's just 2 of us. So we really are a small group. And we did want to do more things like that, but we just haven't been able to put any time towards it. Yeah, I know that's one of the challenge, and ultimately, being supportive to the data scientists and their issues. Yeah, we haven't quite been able to find out the right way to build something like that that would add more value to them.
So maybe just to add to that comment, one of the questions that I've seen, and one of the values, I think one of the huge leverage factors that systems like yours could add, if you will, to the overall system, is to say to an analyst or a data scientist, if you ask that question, it's almost the recommender software question. If you ask that question, why aren't you asking this question? Because typically, a lot of our systems are built presuming that the person initiating a query knows what they're doing. And they don't always know what they're doing. They may know some of what they're doing, but they may be able to do much better. And wouldn't it be great if we could go back to the data scientist, the analyst, whoever's asking the question and saying, well, here's your answer, but by the way, here's a better question to what you're trying to do. Just a thought.
Yeah, it certainly seems like a good idea. I guess just to play devil's advocate a little bit, because I do like that, and there's a lot of value in that. I guess one thing I also worry about on the flip side is would that begin to influence the questions that the data scientists are asking? And then how would that ultimately shape things or push things in one direction? So yeah, if we're bringing people in from all different perspectives, all different viewpoints, does the system kind of push them all in a certain direction? Or, yeah, I don't know, because there certainly is good value there. I guess that would just be a worry that immediately came to mind.
Yeah, you're right. I think I see that too.
Because yeah, they do, these initial queries within this this Pontifex system that we have, the whole system, the query that we put in is just saying get all tweets, all profiles, all followers from this set of people. And then once that question, or once all that data is in the database, then the data scientists will query the database from there, and then they'll, that query is way more specific and just dives into the information they might be looking for. And I think that's where, I feel like that's where that query suggester would come into place, kind of at the end of the pipeline. Once you start to like filter down some of the information into more specific things. Whereas this is kind of like the big casting net that we throw out to get all that to then query down.
That's fair. I understand, and I really do understand the question regarding, you know, if you start recommending things to people, will they then, will their thought process be biased by something that you created, you know, earlier, and may or may not be germane to the problem they're trying to solve. But if I keep using the term analyst, and which may or may not be the same as a data scientist, I'm not totally sure we have a great definition for data science. But you know, I guess I have a lot of confidence in the ability for people to reason, and therefore I think if machines can help them, we ought to at least consider doing that.
Yeah, that's a good point. We have talked about studying algorithmic bias, and that would be an interesting thing to come out of it, is just, yeah, that learning process of figuring out like where are the hangups, or where does this get introduced? And yeah, it is really interesting.
Yeah, this is an awesome discussion. We're kind of coming up at the top of the hour here. We'll go ahead and give a last call for anything else that we want to ask. All right, we'll call that the official end.